Let me introduce to you this symbol E. In mathematics, we call this as the Euler number. It has an approximate value of 2 and 72 hundredths. Just like pi, E is also an irrational number since it is a non-terminating and non-repeating decimal. Can you find it in your calculator? Try to press it and check its numerical value. Most of the time, it is on the second function of the key ln in your calculator.
One of the most important exponential function is y equals e raised to x, where the Euler number is the base. This time, let us study the graph of f of x equals e raised to x. What do you notice as x approaches positive infinity? Take note that the graph rises without bound as x approaches positive infinity. Thus, we can write it mathematically that the limit of e raised to x as x approaches positive infinity is positive infinity. This is confirmed using table of values. We substitute several values for x. As x approaches positive infinity, we can see that the values of f of x increases infinitely. Therefore, the limit of e raised to x as x approaches positive infinity is positive infinity. What if f of x is equal to e raised to negative x? Study the graph of this function. Notice that as the value of x decreases, the value of f of x increases without bound. On the other hand, as the value of x increases, the value of f of x gets closer to 0. From this, we can say that the limit of e raised to negative x as x approaches negative infinity is positive infinity, and limit of e raised to negative x as x approaches to positive infinity is 0. Using table of values, we can see that our first assumption that the limit of e raised to negative x as x approaches negative infinity is really equal to positive infinity. Let's have more examples of finding the limit of natural exponents. Find the limit of e raised to x minus 1 all over x as x approaches 0. Substituting 0 to x, we will have a denominator of 0. Recall that the function does not exist when the denominator is 0. To find the value at which the function approaches 2, we can use either table of values or the graph of the function. Now we evaluate the left side limit of the function. As x approaches 0 from the left, the value of f of x approaches 1. Hence, we will have the limit of e raised to x minus 1 all over x as x approaches 0 from the left is 1. Evaluating the right side limits, we get values which are greater than 0. As you can see, as the value of x approaches 0 from the right, the value of f of x approaches 1. Hence, we can say that the limit of e raised to x minus 1 all over x as x approaches 0 from the right is 1. Now, since both sides of the limits are equal to 1, therefore, we can conclude that the limit of e raised to x minus 1 all over x as x approaches 0 is 1. Let's verify our answer to the graph of the function. We can clearly see that as x approaches 0 from the left, the function gets closer to 1. Tracing the graph from the right, we can see that as the value of x approaches 0, the value of the function gets closer to 1. Therefore, the limit of e raised to x minus 1 all over x as x approaches 0 is 1. Now that we know that the limit of e raised to x minus 1 all over x as x approaches 0 is 1, how can we find the limit of 2e raised to x minus 2 all over x as x approaches 0? Extracting the common factor 2 in the numerator, we will have the limit of 2 times the quantity e raised to x minus 1 all over x as x approaches 0. Applying the limit laws, we can write the given expression as 2 times the limit of e raised to x minus 1 all over x as x approaches 0. We know that this expression is just equal to 1. We can have 2 times 1. Simplifying further, we will have 2. Therefore, the limit of 2 e raised to x minus 2 all over x as x approaches 0 is 2. Let's try graphing the given function to confirm whether the limit is really equal to 2. Looking at the graph, as x approaches 0 from the left, we will have 2, whereas as x approaches 0 from the right, we will also have 2. Let's summarize important concepts we have just learned. Remember that first, the limit of e raised to x as x approaches to positive infinity is positive infinity. Second, the limit of e raised to negative x as x approaches to positive infinity is 0. Third, the limit of e raised to x as x approaches to negative infinity is 0. Fourth, the limit of e raised to negative x as x approaches to negative infinity is equal to positive infinity, and that the limit of e raised to x minus 1 all over x as x approaches 0 is 1.